Hey, good morning, students. I know it's about lunchtime for you, so I thought you'd like to supplement your diet with some vectors. 10.5 is over vectors. So let's start. Vectors are quantities that have both magnitude and direction. Magnitude is how much, direction is where it's going. Examples, 5 miles per hour north or 5 units at pi over 3 radians. Right here we have a picture of a vector. The initial point has the tail. The terminal point has the head. They're always symbolized as lines. In real life, they're typically used in physics to show forces and accelerations because it's important to know where things are going. Okay? So, some terminology. Equivalent vectors have the same magnitude and direction. U, V, and W are the variables often used to denote vectors. The vector formed from the addition of two or more other vectors is called the resultant. The length or magnitude of a vector is written with the two arrows on either side of the vector. Okay? We see that? Vectors are written in something called component form. It has A and B. V is E, and notice there's caret symbols instead of parentheses. The magnitude of a vector is equal to the square root of A squared plus B squared. Alarm bells should be ringing in your head. Oh my gosh, no! It's okay. Vectors can be complex. That's why we're seeing A and B, and why the magnitude of our vector, which is called the norm, looks very similar to you guys. Anyway, I would like you to copy the beige box on page 659 into your notes. It shows the vector properties used for scalar operations. These are things like addition, subtraction, multiplication, division. Finally, one term that you need to know is that equilibrium is the point at which two physical forces are equal. In other words, when you add two vectors, they will equal 0. Okay? Here are the exercise examples from the book I have chosen for you today. There's only 10 or 11 problems. It should take you about 20 minutes to get through the homework tonight. Super easy. So, when we're finding the magnitude of a vector given 2 points, what it's essentially asking us to do is find the length or the distance. So let's just plug our distance formula in there. Boom, 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 boom. Get our answer. Okay? The distance formula is right here on top. D is equal to x2 minus x1 squared plus y2 minus y1 squared and the square root of the whole thing. All right? Now, this question asks us to find a vector equivalent to PQ that starts at the origin. You need to use the formula that's on page 6654. All it asks you to do is say that x2 minus x1, y2 minus y1. So distance formula minus a step. Okay? Very simple. Now, for addition, subtraction, multiplication, and division of vectors, you're basically just going to be doing it normally, except the x and the y terms are going to be kept separate. So right here I did a 3u minus 2v, part of question number 12. We can see u is 4, 0, and v is 1, negative 3. So I take the 3 and I multiply it by each of the x and the y, because we're multiplying 3 by the whole vector, and 2 times the x and the y because we're multiplying it by the whole vector. Okay? Now we're going to take our vectors, we're going to take the x's and subtract them, take the y's and subtract them. That's how we get our final resultant. Okay, so question 25 is a little bit more complicated. 24 is very similar to it. It's just 2 steps, guys. You're going to add all the vectors together and then find a vector that, when it's added to it, produces 0. Our resultant vector was negative 8, negative 2. If we add 8, 2 to it, everything will turn to 0. So when you're asked to find something in equilibrium, you want to find a vector so that when they are added, both the A and B terms are 0. All right, guys, that's it. Let me know if you have questions from the homework, questions from 10.4. You guys are doing great. I love the communication. I'll see you tomorrow.